Okay, good morning all, Mr. Shugan here. So we will proceed with our tutorial discussion for chapter 5 so again, as a reminder, make sure you guys try dulu soalan tutorial baru rujuk video ni and check your answers Okay, so we will continue with week 13 hour 3 face to face question. Okay, so the first question tu 2A2 is definition lah. So they ask us to state Dalton's law of partial pressure Okay, so let's look at the definition first. Okay, so Dalton's law of partial pressure states that the total pressure of a mixture of gases is the sum of the partial pressure of all the components in the mixture. So maksud dia dekat sini, let's say in a system you ada lebih than one type of gas and they do not react with each other. Okay, so each gas tu ada pressure dia masing-masing. Okay, so itu consider sebagai partial pressure of that gas. Kalau nak cari total pressure, we just add up the value lah. So I'll just give a very simple example Let's say lah, you have a closed jar. Okay, and then you have two types of gas. For example, let's say you have a helium gas and you have a hydrogen gas. Okay, it's a mixture of gas mixture of unreacting gas, maksudnya dia tak react antara satu sama lain lah. Okay, so katakanlah pressure helium tu okay adalah 2 atm. Okay, and then the pressure of hydrogen adalah 3 atm. Just an example so maksudnya di sini adalah okay, dalam sistem tu okay, partial pressure of helium gas adalah 2 atm dan partial pressure of hydrogen gas adalah 3 atm. So if you want to find the total pressure, okay, we just add up, just tambah sahaja the partial pressure punya values. Okay, so this is just an example actually hydrogen to H2 lah, hydrogen gas okay, alright. Okay, so the next question, okay, so says a gas mixture containing 2.45 gram of nitrogen gas and 3.10 gram of neon occupies a volume of 2.5 liter. What is the pressure of the gas at 25 degrees Celsius? Okay, so sekarang dia gas mixture, ada dua benda di dalam mixture tu. Pertama sekali adalah nitrogen gas and then you have neon gas. Okay, so volume dah diberi 2.5 liter. Okay, and then temperature is 25 degrees Celsius. Okay, so untuk gas pula dia bagi kuantiti dalam bentuk gram. Okay, dia bagi kuantiti dalam bentuk gram. Okay, so what we have to do here, we have to find the partial pressure of each gas. Maksudnya kita kena cari partial pressure gas N2, nitrogen gas, dan partial pressure of neon gas. Okay, and then we use PV equals to nRT to find the partial pressure of each gas, and then nak cari total pressure gas mixture tu, we just add up the values lah. Okay, so we do one by one Okay, so just hold on. Okay, so first what we need to do, we need to find the mole first, baru kita boleh kira partial pressure of gas nitrogen dengan neon gas lah. Okay, using this ideal gas formula, PV equals to nRT. Okay, so to find the number of mole, kita kena convert mass kepada mole. So we have to divide by molar mass lah. Okay, so we do one by one. Kita cari dulu mole N2. Okay, so mass dia adalah 2.45 gram. Okay, so you have two nitrogen. The mass of each nitrogen, the molar mass is 14 gram per mole. Okay, so you should get 0.0875. Okay. Alright, next what we do, we find the number of mole of neon gas pula. Okay, so 3.1 gram. Okay, so the molar mass of neon is 20.2 gram per mole. Okay, so the number of mole that you should get is 0.153. Okay, alright. So again, kalau dia diberi dalam bentuk mass, the quantity of the gas tu, kita kena convert dia kepada mole, baru kita boleh selesaikan using the ideal gas equation to find our partial pressure for each gas lah. Okay, so next what we do, we have to solve one by one. Okay, so we have to find partial pressure of N2 and partial pressure of neon lah. So we just rearrange our ideal equation to, okay, PV equals to nRT. Okay, so you have N, number of mole of nitrogen gas, R T over volume. Okay, so number of mole kita dah kira tadi 0.0875 mole. Okay, again gas constant, gas constant is 0.08206. So unit gas constant ni panjang sedikit, but make sure you should know you should know the unit. Okay, and then make it a habit to write the units in your calculation. Baru kita tahu apa unit yang akan tinggal nanti in our final answer. Okay, and then temperature is given in degree Celsius, 25 degree Celsius. So you juga perlu tahu how to convert to Kelvin lah. So we must add 273 tambah 273 will give you 298 Kelvin. Okay, and the volume is also given, which is 2.5 liter. Okay, so the partial pressure for nitrogen gas, partial pressure for nitrogen gas that you should get is 0.856 atm. Okay, 0.856 atm. Okay, so next what you need to do, you need to calculate pula partial pressure for neon. Okay, partial pressure for neon. Okay, use the same step here. Okay, use the same steps to calculate the partial pressure for neon. Okay, the only difference is the number of mole. Kalau untuk nitrogen is 0.0875, untuk neon adalah 0.153 mole. Okay, the rest, the gas constant, the temperature and the volume are all the same. Okay, so I want you to solve this by yourself. So the partial pressure for neon that you should get is 1.497 atm. Okay, so make sure you get this answer, partial pressure for neon. So finally what we have to do, we have to find the total pressure. So total pressure, like I told you, we add up the partial pressure lah, which is partial pressure of nitrogen gas plus partial pressure of neon, which is 0.856 atm plus 1.497 atm. So your final answer that you should get is 2.35 atm. So I hope tak ada masalah dengan soalan ni. Okay guys, we will continue with question 2C. So the question still involves partial pressure. So 4 liter of nitrogen gas, okay, at a pressure of 400 kilonewton per meter square, and 1 liter of argon gas at a pressure of 200 kilonewton per meter square are transferred into a 2 liter container. Okay, so the first two they asked to calculate partial pressure for nitrogen and partial pressure for argon. Okay, so mungkin ada pelajar yang berfikirlah, kenapa perlu calculate partial pressure sedangkan nilai pressure tu diberi. Okay, so if you notice okay, for example nitrogen gas initial volume dia 4 liter, and then kita transfer dia ke dalam 2 liter container. Same goes to argon. Okay, initial volume dia adalah 1 liter, kita transfer dia ke dalam 2 liter container. So volume dia berubah, that means the pressure also will change. Okay, so that is why we need to calculate the partial pressure for each gas in the container tu, sebab volume dia dah berubah. Okay, so how do we do that? So if you notice, we have, for example, untuk nitrogen kita ada initial volume dia, kita ada initial pressure dia, and then kita ada final volume, which is the volume of the container. So what we need to find now is the final pressure lah di dalam container tu. So what we do, we can use Boyle's law lah, which is P1 V1 equals to P2 V2. Okay, so we will solve for nitrogen gas first lah. So again, pressure tu kita tak perlu tukar kepada ATM. We can just use kilonewton per meter square. Okay, so the initial volume is 4 liter. Okay, so the final pressure yang kita nak cari lah. So I will write as partial pressure of nitrogen, and the volume is 2 liter, the volume of the container. Okay, so solving this will give you the partial pressure of nitrogen as 800 kilonewton per meter square. Okay, actually melalui relationship antara pressure dengan volume in Boyle's law, you can determine lah what is the pressure value. Okay, so maksudnya volume dia berkurang daripada 4 liter kepada 2 liter, the volume become half. So the pressure should double lah. That means from 400 kilonewton per meter square to 800 kilonewton per meter square. Okay, so again recall back the relationship tu. Okay, so pressure is inversely proportional to the volume. Maksudnya kalau volume tu berkurang, pressure tu akan bertambah. Okay, so we do the same thing to find the partial pressure of argon gas. Okay, so the initial volume of argon gas is 1, and then the initial pressure is 200 kilonewton per meter square. Okay, so the final pressure yang kita nak cari lah, so we can write it as partial pressure of argon. Okay, the final volume tu sama juga, iaitu volume of container, which is 2 liter. Okay, so solving this should give you 100 kilonewton per meter square. Okay, so again looking at the relationship, volume dia tu double, so the pressure should reduce by half lah. That means from 200 to 100. Okay, and then the final part tu 3 Roman, they ask you to find the total pressure. Baru kita add up the pressure value. So ingat jangan bila you selesaikan, jangan terus add up the pressure value yang diberi dalam soalan. You kena tengok volume container tu sama ke ataupun berbeza dengan volume asal gas tu. Okay, so the total pressure will be partial pressure of nitrogen plus partial pressure of argon. Okay, so here nitrogen gas is N2. Okay, so partial pressure of nitrogen gas is 800 and argon is 100 kilonewton per meter square. Okay, so this should give you 900 kilonewton per meter square. Okay, now we will proceed with question number 3. Okay, so this is actually question number 3. Okay, So by using water displacement method, okay, 128 ml of oxygen gas was collected from the decomposition of potassium chlorate at 24 degrees Celsius, and atmospheric pressure diberi 762 millimeter mercury. Okay, so they asked us to calculate the mass of oxygen gas obtained. Okay, calculate the mass of oxygen gas obtained. And then next, the vapor pressure of water at 24 degrees Celsius was 24 millimeter mercury. Okay, so kalau you notice kat sini, okay, this one is still water displacement method, but ada extra step yang you kena take note of lah. Okay, pertama sekali dia ada beri dua nilai pressure, iaitu atmospheric pressure, okay, atmospheric pressure dan vapor pressure of water. Okay, so you kena tahu daripada values ni macam mana kita nak cari di pressure of oxygen gas. Okay, so what you need to understand first is the total pressure ataupun kita punya atmospheric pressure. Our total pressure tu is our atmospheric pressure is equals to partial pressure of oxygen gas plus partial pressure of water vapor. Okay, so this is the extra step that you need to know for this question. Alright, so total pressure ataupun atmospheric pressure is equals to partial pressure of oxygen gas plus partial pressure of vapor plus the partial vapor pressure of water. Okay, so the total pressure ataupun atmospheric pressure is 762 millimeter mercury. Okay, so the first step you kena cari dulu kita punya pressure of oxygen gas. Okay, baru kita boleh selesaikan menggunakan PV sama dengan nRT untuk nak cari di mass of oxygen gas obtained lah. Okay, so and then the vapor pressure of water is given as 24 millimeter mercury. Okay, so solving this will give you the pressure of oxygen gas as 762 millimeter mercury minus 24 millimeter mercury. Should get 738 millimeter mercury. Okay, so before we solve the equation, okay, to find the mass tu, apa kita kena buat? Kita kena convert dulu pressure in millimeter mercury ni kepada ATM lah. Okay, so again, how to convert? Okay, so the pressure tu nak convert kepada ATM. So kalau millimeter mercury saya dah bagi tahu, you have to divide by 760 lah. Nak tukar dia kepada ATM, to convert from millimeter mercury to ATM, you have to divide by 760. Okay, writing the units like this can show that the millimeter mercury will cancel off lah, leaving you with only ATM. Okay, so your pressure of oxygen gas tu should be 0.971 ATM. Okay, alright. So next, you need to find the mass of oxygen gas. Sebab sekarang kita dah ada pressure. Okay, so pressure of the gas, volume of the gas dah diberi. Okay, temperature dah diberi. So kita boleh solve lah. Okay, so actually ada dua cara lah. Pertama sekali, you pakai PV sama dengan nRT. Okay, cari dulu mole oxygen gas. Okay, and then you times by the molar mass of oxygen gas lah, to find the mass of oxygen gas obtained. Ataupun kita boleh buat apa? So kita dah belajar. Okay, this is our ideal gas equation, PV equals to nRT, and we can modify this straight away. Number of mole is mass divide by molar mass, RT. Okay, so rearrange this equation. Okay, the mass will be P times by volume times by molar mass over RT. Okay, so to find the mass of oxygen gas, So the pressure is 0.971 atm. Okay, so the volume is in milliliter, so you must change to liter lah. Divide by 1000, should be 0.128 liter. Okay, and the molar mass of oxygen gas. Okay, so one oxygen is 16 gram per mole. Okay, oxygen gas kena ingat O2 so darat 2 will give you 32 gram per mole. Okay, and then the gas constant 0.08206. Okay, unit dia liter atm per mole per Kelvin. Okay, and then the temperature is 24 degrees Celsius. Okay, 24 degrees Celsius, you have to change to Kelvin, you must plus 273 lah, so you should get 297 Kelvin. Okay, right. So solving this will give you 0.163 gram. Okay, so this is the mass of oxygen gas that you should get lah. Okay, so again just to recall so you kena faham yang total pressure ataupun kita punya atmospheric pressure tu, total pressure tu adalah apa pressure yang wujud dalam tu. Okay, so first is the gas tu. Okay, second is the vapor pressure of water tu. Okay, so ada dua pressure lah. Okay, so total pressure ni is our atmospheric pressure. Okay, pressure of our gas tu, oxygen gas yang kita nak kira. And then vapor pressure of water ni dah diberi dalam soalan lah, which is 24 mm mercury. So this step you kena faham dulu, how to find the pressure of our gas. Okay, once we get the pressure, and then we can find other quantities yang dikendaki oleh soalan lah. Okay.